The most popular AI tool in the world has been hacked hundreds of times, not by some nation state, by security researchers who spent about 10 minutes looking. One crafted link, and they had full access to your machine. Code execution, file system, everything. And this tool has 335,000 GitHub stars. Millions of people are running it right now. And the thing that was supposed to stop this? A system message. A few lines of text telling the AI, please don't do anything dangerous. That's it. That's the guardrail. It's sitting in the same process as the agent, in the same memory, readable and modifiable by the very thing it's trying to control. That's application layer security. And it's the digital equivalent of asking the prisoner to guard the prison. Here's the backstory. OpenClaw launched in November 2025 and became the fastest growing open source project in history. 335,000 GitHub stars in 4 months. It blew past React's 10-year record in 60 days for good reason. It gave anyone a personal AI agent that could write code, browse the web, read your files, install packages, all running locally on your machine with your full permissions. Then the security researchers showed up. In February 2026, they found a vulnerability scored 8.8 out of 10 on the severity scale. One crafted link sent to any OpenClaw user, and the attacker could execute arbitrary code on their machine. No confirmation dialog, no permission prompt. One-click full access. They called it CVE 2026-25253. And it kept getting worse. A flaw called clawjacked let malicious websites hijack your local OpenClaw agent through WebSocket connections. You visit a website, and now that website is controlling your AI agent. Researchers then scanned ClawHub, the official skills marketplace, and found over 800 malicious packages. That's 20% of the entire registry, delivering malware straight through the agent you trusted. Then came the final number. Security scanners found over 30,000 OpenClaw instances sitting on the public internet with no authentication, no password, no firewall, just an open door. 335,000 stars, real security vulnerabilities, and millions of users running an agent with full system access. Something had to change. You'd think the fix is obvious: better prompts, stricter system messages, more guardrails. But here's the fundamental problem. Those guardrails live inside the same process as the agent. The agent can read its own system message. It has to read it. That's how it knows what to do. Which means a compromised agent or a cleverly crafted prompt injection can override, rewrite, or simply ignore those instructions. The guard and the prisoner share the same cell. Now think about how your browser handles security. When you visit a website, it can run JavaScript, make network requests, access your camera and microphone. That's a lot of power, but it can't read your hard drive. It can't install software. It can't touch other tabs. Every website runs in a sandbox that's enforced by the browser at the operating system level. The website doesn't choose to be safe. It doesn't promise to behave. The sandbox forces it from the outside at a layer the website can't reach. AI agents don't have that. They run directly on your machine with your user permissions, your files, your network, your credentials. And the only thing between them and full access is a polite suggestion in a prompt. NVIDIA looked at this gap and said, we need the browser tab model, but for AI agents. Security enforced from the infrastructure level, outside the agent's process, at a layer it can never touch. NemoClaw is NVIDIA's answer. Open-sourced at GTC 2026 under the Apache 2.0 license. It's not a new agent. It's a security cage that wraps around OpenClaw. One command to install, and once it's running, your agent operates inside kernel-level isolation that it cannot escape, even if it's been completely compromised. The sandbox is the core of the system. It's built on a runtime called OpenShell, and it uses 3 Linux kernel security features working together. First, Landlock. This controls exactly which files the agent can access. Inside the sandbox, the agent can read and write to its sandbox directory and temp. That's it. Your home folder, your documents, your .ssh directory with your private keys. None of that exists to the agent. Second, seccomp. This filters every system call the agent tries to make. Operating system calls like create a new process, change my permissions, or load a kernel module. Seccomp intercepts these at the kernel level before they execute and blocks anything dangerous. The agent can't escalate its privileges because the kernel won't let it. And third, network namespace isolation. The agent starts with 0 network access. Not restricted access, 0. Every outbound connection, every API call, every domain has to be explicitly approved by the operator. You whitelist exactly what the agent is allowed to reach, and everything else is blocked. And this isn't a one-time setting. If the agent discovers a new endpoint and tries to call it, the system blocks the request and pops up a real-time approval prompt for the operator. The agent doesn't decide what it can access, the operator does. Now you might be thinking, why not just use Docker? Docker isolates processes, and it's been around for over a decade. But Docker doesn't understand AI agents. It can't evaluate what the agent is doing at a semantic level. NemoClaw is agent-aware. It evaluates policies based on what binary is running, what destination it's calling, what HTTP method it's using, and what path it's requesting. If the agent learns a new skill at runtime, that skill has to be verified before it can execute. Docker gives you a box. NemoClaw gives you a guard that understands what's inside the box. There's one more piece most people miss. When your AI agent calls a model, it needs an API key. Normally, that key sits in an environment variable inside the agent's process. If the agent gets compromised, those credentials are exposed immediately. NemoClaw changes this. It stores your credentials on the host machine, completely outside the sandbox. The agent calls a local endpoint called Inference.local, and the request crosses the sandbox boundary, and NemoClaw injects the real API key on the other side. The agent never touches your credentials, and the operator controls where each request goes. Sensitive data? Route it to a local model running on your own GPU chip. Nothing leaves the machine. General queries go to the cloud. The agent doesn't even know which model answered. It just gets a response from inference.local. NVIDIA ships their own Nematron model for local inference, but the system is completely model agnostic. You can plug in OpenAI, Anthropic, Google Gemini, even a local Llama server. The routing is invisible to the agent. We've seen this pattern before. A new technology explodes. Everyone rushes in. Security comes later, usually after something breaks. It happened with the web. It happened with mobile apps. It happened with cloud computing. And now it's happening with AI agents. OpenClaw was the everyone rushes in phase. NemoClaw is the now let's do this safely phase. NemoClaw is still alpha. It's not production ready yet, and the interfaces will change. But NVIDIA isn't building alone. Cisco, CrowdStrike, Google Cloud, and Microsoft Security are all building alongside them, aligning their security tools with the OpenShell sandbox runtime. The sandbox itself, OpenShell, is its own open source project with nearly 4,000 GitHub stars. And the entire stack is Apache 2.0 licensed, free, and installs with a single curl command. So here's the takeaway. If you're running an AI agent on your machine right now, the question isn't whether you trust the model. It's whether you trust the cage around it. Because right now, most agents are running with your full permissions, your file access, your network, and your credentials, protected by nothing more than a polite suggestion in a system prompt. The fix isn't a better prompt. It never was. The fix is a better cage.